This is part 6 of our video series in support of sampling distribution theory. I'm Renee Clark from the Swenson School of Engineering at Pitt. In this video, we are going to do additional examples of using the Z probability table that's found in the back of most inferential statistics books. This is a direct continuation of part 5 in the video series. In the back of your textbook, as I had indicated, there are 2 pages of probabilities under the Z-curve, or the standard normal curve. In the prior video, we looked at values of Z that were negative, okay? Now we're going to use the page 736, that has positive values of Z. Okay, so if I draw in the legend here, these are values of Z that are to the right of the mean of 0. Okay, so as you can see from circling the row headers, these are positive values of Z. The column headers are the same as in the previous video. From this table, you can tell that Z is as large as 3.49. Okay. But on this table, the probabilities are still those to the left of the Z value. Even though there is not a legend shown on this page, the legend is the same. It's showing probabilities that are to the left of the Z value. Okay? So, if we wanted to determine the probability Z less than 1.96, we would do the same thing as previously. We would find 1.9 in the table. Okay? We would find 0.6 column header, and we would read off the probability that's at the intersection of those, which is 0.9750. So the probability Z less than 1.96 is 0.9750. Okay, now, important related question. What if we wanted to know the probability Z greater than 1.96? So we just determined the probability Z less than 1.96. What if we want probability Z greater than 1.96? Very simple to determine. You will remember that under the normal curve, any normal curve, the total area or the total probability under that curve must equal 1. Okay, so if we want the probability Z greater than 1.96, it's equal to 1 minus the probability Z less than 1.96, right? Because we were to draw this in here, here's 1.96, okay? The probability that Z is less than 1.96, which is in green, plus the probability Z greater than 1.96, which is in blue, must equal 1. Okay? So this will be 1 minus probability Z less than 1.96, which we determined just above to be 0.9750. And when we do the math on that, that's equal to 0.025. So that is the answer to this question. So the area in blue here, 0.025. Area in green, determined initially, 0.9750. Let's do one additional example, which is something that you will likely be asked to do frequently, is to determine that the probability that z is between two numbers. Okay, so for example, in this case, we're being asked to determine the probability that z is between 1.25 and 2.54. Okay, with this type of a problem, I always start by drawing a picture. It's very helpful. So z curve, mean of 0. We're being asked to determine that z, which sits along the x-axis, is between 1.25 and 2.54. Okay, so it's actually the area that's shaded in yellow under the curve. Okay, can you see that if you take all the area under z to the left of 2.54 in blue, and you subtract off all the area to the left under the curve to the left of 1.25, which is in purple, what you're left with is the area in between, which is the yellow shaded area. Okay? So, therefore, if we want to find the probability that z is between 1.25 and 2.54, or another way to write that is the probability that 1.25 less than z less than 2.54, we simply take the probability that z less than 2.54, or all the probability to the left of 2.54, we subtract off all the area or probability that z is to the left of 1.25, just like I showed above. Okay? To get these values, we simply can read them off the table. Okay? 2.54, the value at the intersection there is 9945. So 0.9945. Subtract off probability z less than 1.25. Remember, these probabilities that are shown in these tables are areas to the left of z. Okay? Probability z less than 1.25, 1.25. The probability at the intersection of those two is right there, 0.8944, 0.8944. And when you subtract those two numbers, you come up with 0.1001. Okay, that's the final answer. So the probability that z is between 1.25 and 2.54 is 0.1001. Thank you to the National Science Foundation for supporting our work under Grant 233-5802. Thank you for watching.